Together, an apple and a banana contain 190 calories. 3 apples and 2 bananas contain 465 calories. How many calories are there in a single apple and in a single banana? Since they're asking for the number of calories in an apple and in a banana, we're going to let those be our variables, x and y. So let's let calories in an apple be x, and let's let calories in a banana be y. Now we have 2 variables, so we're going to need to write 2 equations that model the situation. We're told that an apple and banana contain 190 calories together. So if we add the calories in an apple plus the calories in a banana, we should get 190 in total. So we have x plus y equals 190. Then 3 apples and 2 bananas contain 465 calories. Well, if we're looking at the calories in 3 apples, that's going to be 3x. And then if we also have 2 bananas, that'll be plus 2y. And that equals 465 in total. We need to solve this system of equations, and we could use substitution or elimination. I have a slight preference for substitution, especially in this problem, because in the first equation, neither x nor y in the first equation has a leading coefficient. We'll be able to isolate x or y without having to perform any division. It doesn't really matter which one we isolate, so let's isolate x. To get x alone, we can subtract y from both sides. And when we do that, this tells us that x is 190 minus y. Now, what we're going to do is we're going to take this and substitute it into the other one. Wherever we have x, we're going to replace it with 190 minus y. So we have 3x plus 2y equals 465. So that 3x is going to become 3 times 190 minus y. We're replacing x with 190 minus y. But we also have the other term, plus 2y, and that's going to equal 465. Now we only have y in the equation, so we want to solve for y. We can start by distributing the 3. 3 times 190 is 570, minus 3 times y is 3y. So we have 570 minus 3y plus 2y equals 465. We can combine like terms on the left. Negative 3y plus 2y is negative y. So we have negative y plus 570 equals 465. To get rid of that constant term, we're going to subtract 570 from both sides of the equation. When we do that, we're left with the opposite of y equals negative 105. To get y alone, to make y positive, we can divide both sides by negative 1. This effectively changes the signs on both sides. That gives us a positive y equals positive 105. So we know the value for y. We need to figure out what x is. And we had this equation earlier, x equals 190 minus y. This is a great one to plug in 105 for y because our goal is to solve for x, and x is already isolated here. So let's plug it in. We have x equals 190 minus y, which in this case is 105. And 190 minus 105 is 85. So when we go up to our let statements, the calories in an apple was equal to X, and that's going to be 85. The calories in a banana was represented by Y, and that's 105. So they ask how many calories are there in a single apple and in a single banana. We can say there are 85 calories in an apple and 105 calories in a banana. And that is our final answer.